Hello, my name is John Phillips, and today I'm presenting on Niels Bohr. So, Niels Bohr was born in 1885 in Copenhagen, Denmark, and he grew up around science. His father was a famous physiology professor, so Bohr grew up hearing academic things, scientific things at his dinner table. Being around his environment would make him naturally curious about how the world works. He ended up studying physics in his hometown at the University of Copenhagen, where he stood out because he wasn't just smart, he thought very differently. After earning his doctorate degree, he went to England and worked with Ernest Rutherford. Ernest Rutherford was the same scientist who discovered the atomic nucleus. Working with Rutherford really changed Bohr's direction and helped him shape the ideas that later made him one of the most important figures in atomic and nuclear chemistry. So before Bohr's big breakthrough, scientists had a huge problem. According to physics that they understood at the time, atoms shouldn't have been able to be stable. So if electrons were really orbiting the nucleus, like planets were orbiting around the sun, they should have been losing their energy and crashing into the nucleus, but obviously atoms don't just collapse. At the same time, scientists kept seeing something else that they thought were very weird. Every element would produce its own unique color of light when it was heated or electrically excited. Those were called spectral lines, but they couldn't explain why they were doing it at that time or why it was different for each element. Bohr thought that he should combine Rutherford's nuclear model with the new ideas from quantum theory, and then once he connected these two ideas, he created his own model. So in 1913, Bohr published his own atomic model, and it completely changed science. He proposed that electrons don't move around randomly, they stay in specific energy levels or orbits. If an electron absorbs energy, it jumps to a higher orbit, and when it falls back down, it gives off that energy as light. Suddenly, the weird spectral lines that they saw earlier actually were making sense now. They were caused by electrons changing orbits. So for the first time, the structure of the atom and the way it gives off light were connected in a simple model. The best part about Bohr's model was that the math actually made sense. So when Bohr calculated the energy levels of the hydrogen atom, his numbers lined up exactly with the bright line spectrum that scientists had already observed for years in labs. So every line was just an electron dropping from one orbit to another. This was the first real evidence that the atomic energy comes in fixed amounts. It also showed that the nucleus with its positive charge directly controls how electrons behave. Bohr proved that the nucleus isn't just sitting in one spot, it's shaping the entire atom. Now we're going to move on to how Bohr shifted from atomic structure into nuclear physics, and this is where he develops the liquid drop model, and he later creates the first real theory of nuclear fission. In the 1930s, Bohr introduced something called the liquid drop model. He imagined the nucleus as a drop of liquid held together by nuclear forces. It might sound weird, but it helped explain how the nucleus could stretch, vibrate, and sometimes become unstable. At the same time, scientists were discovering nuclear fission, but they couldn't understand or explain it. So Bohr realized that when a heavy nucleus absorbs a neutron, it becomes excited, kind of like shaking a water balloon, and if it stretches too much, it pinches in the middle and splits into two smaller pieces, and that's basically the foundation for nuclear fission. In 1939, Bohr and another physicist created the first mathematical theory of nuclear fission. They show that when a heavy nucleus, like uranium-235, absorbs a neutron, it gains energy and becomes unstable. And if it gains enough energy, the nucleus can't hold itself together anymore, and it's going to scrunch and pinch, and then it's going to split into two smaller nuclei. And this happens usually around the mass numbers of 95 and 140, so elements like plutonium and thorium can undergo fission, and especially when they're bombarded with neutrons. Also, each of the fission events releases 2 or 3 neutrons, and that's a huge amount of energy, and that chain reaction is what powers nuclear reactors today, and it was also the basis for earlier nuclear weapons. Bohr's life changed a lot during World War II. This was when the Nazis were taking over. So he fled Denmark in 1943 and eventually made it to the United States. In the United States, he became part of the Manhattan Project. He wasn't one of the engineers building the bombs, but he was a key advisor because of his deep understanding of fission and neutron behavior, his ideas helped scientists refine the design of the first nuclear weapon. After the war, Bohr took a completely different stance. He pushed for peaceful uses of nuclear energy, and he argued for international cooperation. He proposed an open world idea where the nations should be transparent about nuclear research to avoid an open arms race. After the war, he returned back to his hometown and rebuilt the Institute for Theoretical Physics. It became one of the world's top research centers for nuclear research, and a lot of famous scientists trained there. His son, I don't know how to say his name, but I'm gonna say Bohr, and his and Ben Mendelssohn. These were later on became Nobel Prize winners for like developing the shell of the model of the nucleus. During this time, Bohr also expanded his concept that the idea is that you often need two different viewpoints to understand one phenomenon. He applied it not only to quantum mechanics, but to philosophy, politics, and like other nuclear responsibilities. Bohr stayed heavily involved about debates about arms control and peaceful use of nuclear energy. Bohr received a ton of recognition for his contributions. He won the Nobel Prize for Physics in 1922 for his atomic model. He was elected a Fellow of the Royal Society and received Denmark's highest honor, which was the Order of the Elephant. And he later earned the Atoms for Peace Award for promoting the responsible use of nuclear technology. Today, the Niels Bohr Institute in Copenhagen is still one of the top research centers in the world, and his influence can be seen across nuclear chemistry, quantum mechanics, and modern physics. So overall, Niels Bohr completely changed how we understand the atom and the nucleus. His atomic model introduced energy levels, and his liquid drop model helped explain fission. And his leadership and like ideology had a huge impact on science and international politics. Even today, with our modern technology, from like nuclear reactors to medical imaging, we still rely on his ideas, or some of the ideas that started with Bohr. And his message about using science responsibly is just as important as it is now to just how it was in the nuclear age. Thank you.